Now in this video we want to start looking at how we can plot points that are symmetric about the what we call the polar axes. That is this what we would think of as the superimposed positive half of the x-axis. So we're just going to plot a couple points and illustrate that they are have that aspect of symmetry. 3, 45 will plot, and the point symmetric to that would be at 3, -45. So let's see that 3, -45. So we'll plot that. Okay. We'll plot something like 6, 30. Okay, and then plot its point symmetric to that, which would be 6, -30. Okay, and we'll plot that. Okay, so as we can see, those points are symmetric about the polar axes, and of course that aspect of symmetry could easily be illustrated by connecting them with lines which are perpendicular to that axis of symmetry, which is what we get when we have symmetry across the axes. Okay, so we'll come back to that in a moment. So we're back and we've summarized here that aspect of symmetry. Okay, so that aspect of symmetry about the polar axes is could be illustrated here with these points: 5 pi over 3, 5 -pi over 3, so that if in a function the angle is replaced with its opposite, having no change in r, then we're going to suspect that that function is symmetric about the polar axes. Okay, is symmetric about the polar axes. Now we know that the cosine, in fact, has that aspect of symmetry. That is, the cosine of a negative angle is the same as the cosine of a positive angle. So we're going to explore that to see that whether or not these cosine functions are going to have that aspect of symmetry. So we'll take a look at that in just a moment. So here we are. We've got this which we're asked to graph. Okay, we're asked to graph 2 cosine of theta. All right, and of course, just as when we learned to graph in x and y, we did point plotting. So we're going to do the same thing here. We're going to do the same exact thing here. We're going to put in values of theta and put them into our cosine first, and then double it up, and then we're going to have those points to plot. Okay, so we're going to put in the values 35, 45, 60, 90, and so on. Okay, and we're going to look at what happens. So putting in 0 in the cosine of 0 is 1, and then twice the cosine would be 2. 30 degrees, or pi over 6, would be √3 over 2 for the cosine. Then doubling that would give us √3. 45 would give us √2 over 2, doubling that for √2. 60 degrees would give us 60 degrees would give us 1/2 at the cosine, times 2 would be 1. Okay, so we'll come back to that in a minute and see how they plot out for us. Okay, so we're back and we plotted these points. Okay, the points as we were plotting, I got this thing to read in radians now. So as we saw, we did something like we did 2, 0, plot it right there. Okay, this point, as we'll see, is going to plot as that's at 30 degrees, but we got it in radians now, so it's pi over 6, and that was at √3. Okay, which is 1.71. Plot that. Okay, and so on and so forth. This point was at 45 degrees, or pi over 4. Okay, and that was a √2 value. Okay, so that was 1.41. Okay, so we plot that. So so now that we've got those plotted, we're going to suspect, as we saw, that the graph of what we're trying to graph is 2 cosine of theta is symmetric about that polar axis, which means each one of these points should have a match below here. So we're going to plot the match points below and see if in fact okay, when we plot our function, that is what we get. So we've got the root 3, which is the 1.71, at a pi over 6 value. So we're going to go negative pi over 6 and plot that, and it's right there, okay? Then we had this root 2 value, okay? The root 2 value, which is 1.41, and we were plotting that at pi over 4 or 45 degrees. So now we're going to go at negative pi over 4, and that should have a plot, okay? So let's put that in. Okay, and this one, which was at 1 and at a pi over 6, so at negative pi over 6, it should have a match. And we'll plot that. That's okay. I think we did that. It's not pi over 6, that's a pi over 4. So it's 1 comma pi over 3, a negative pi over 3. So let's see what we get for that, okay? So there that one is, okay? So those points are all the symmetric points to the ones that we graph, okay? We're going to get this point out of here because it doesn't belong. And lo and behold, if we now ask to graph this, okay, look what's going to happen. All those points are, in fact, on that graph. So this function, if you want to call it that, it's a polar function, is nothing more than a circle. It's a circle. It is a circle, without a doubt. It's a circle, okay? And it's a circle of diameter 2, as you can see here, okay? And it has the aspect of symmetry, about being symmetric about the polar axes, as we can see and as illustrated with the point plotting, okay? So so we'll get back to some more polar graphs and plotting them in the next video.